So good morning everyone. On behalf of Rajendra Mane College of Engineering and Technology Automobile Engineering Department and Industry Institute Interaction Cell, I take this pleasure to introduce today's resource person, Mr. Nachiket Padke. Mr. Nachiket Padke, he has done his diploma in mechanical engineering from Unitai Polytechnic, Pune. He has completed his Bachelor of Engineering in Mechanical from University of Pune. He has worked as lead engineer at Tata Johnson Control Automotive Limited Engineering Division. He has also worked as application engineer at NetShip Corporation. He was director at Node Element Consultancy Private Limited, and at present he is training head and counselor at Eleno Engineering Learning Center Pune, and also he is partner for Eleno Energy LLP Pune. Also, he is editor-in-chief at Heroes of Engineering. Besides this, Mr. Nachiket Padke is also a member of our department academic advisory board, and he is associated with RMCET for almost more than 5-6 years, I think.
Yes.
So, on behalf of RMCET, I welcome him and thank him for accepting our invitation to deliver his expertise in the field of crashworthiness and CAE for our automobile and mechanical engineering students. I also will like to welcome our principal sir, Dr. Bhagwat, HOD Mechanical, Dr. Waghmare sir, and also we are having one faculty member from Maharshi Parshuram College of Engineering, Mr. Prasad Bapat, who was very enthusiastic to see the poster that I want to attend this particular webinar. So I told him that yes, you are always welcome to attend this technical stuff. So I welcome all the dignitaries, and I request Bhagwat sir to share his thoughts, and then we can start with the actual session.
Yeah. So good morning to all. So as Dandage sir has given the introduction of the resource person as well as the webinar. And so we are here for this webinar on the important topic of vehicle design for crashworthiness using CAE technique by the resource person, Mr. Nachiket Padke sir. As he has been introduced by Dandage sir as he is a proprietor of Eleno. Eleno Pune. Even he is on our departmental advisory board of automobile engineering department. So I feel it's really a industry institute interaction in the real sense. So it is really a good initiative taken by Professor Dandage, head of Industry Institute Interaction Cell, as well as the efforts taken by both HODs, HOD Auto as well as HOD Mech, for arranging this particular webinar. And especially I would like to thank Nachiket sir for taking out his time and accepting our request to deliver this particular seminar. So without taking much time, I would like to appeal all the students, sincerely I would like to appeal that you get benefited by this webinar, because you see what you can say, this is the advantage of this particular pandemic situation, that on such a platform we are gathering, and we are inviting the resource person like experts like Nachiket sir. Please take it seriously, ask your doubt, make the session interactive, maybe after the session getting over, but get the maximum benefit of it, as it is the most important topic in like you can say latest technology. Using CAE techniques, he would be telling us or guiding about the vehicle design. So it is the important topic, I feel, and you must get the benefit, because we'll be always in touch with Nachiket sir. He will also guide us from his end, definitely. So we are looking forward for this continuous interaction with Nachiket sir. But only thing on our part, like you can say, we have to ask, we have to make this thing interactive, so that the speaker also will get like enthusiasm to deliver the good knowledge. Okay. So that's all from my side. I wish all the best to all the participants as well as the resource person for this particular webinar. So over to Nachiket sir for this particular session. Thank you very much.
Yes. Thank you, sir. Thank you very much, Rahul sir, Bhagwat sir, and Sachin sir. It's really a pleasure for me to deliver session on crashworthiness. It is always my subject close to my heart. So, guys, learning needs energy. That's the first sentence I'm going to tell you. Okay. So, and for that, I want you guys to be interactive and at the same time attentive. So, whosoever is doing some other work, please put that work aside. Okay. So, I'll give you some 10 seconds. Just put every single work aside. Even my mobile phone is on airplane mode. So I'm not going to get any call. Okay. So make sure for next 1.5 hour, you are completely attentive. Okay. You are coming here. Those who don't want to attend, those who want some kind of distraction in between, just leave from the beginning, because then you will never understand. Okay. So make sure you are attending. If you are attending with full of your senses, type in A in your chat box quickly. I want you guys to be interactive. Okay, don't be just lying down and looking at it, right? So just type in A quick. We are almost 96 people. I want everyone's reply, guys. A. You're attentive, right? Put your mobile phones. If you are attending on mobile phone, don't make it on airplane mode for sure. But if you are attending on laptop, just make sure that you are not getting distracted by mobile phone. Okay, good. Thanks a lot, guys, for replies. This is going to be an interactive session, and interaction will come through chat box. Yes, thank you very much. Thanks, Ameya. Thanks, Lokan, everyone. Thanks a lot. I'm really happy to see energy. Learning needs energy. Every single learning, whatever it can be, it is going to need a lot of energy of your head, of your muscles, everything. The second ground rule is you should be having pen and paper ready. So type in PP if you are ready with pen and paper. Type in PP if you are ready with pen and paper. Pen and paper, quick. I really want you to take a lot of notes. Okay, so this is very, very important topic. This topic is not something which is very close to or very, very much related to what you study in academics, but it uses all the academic fundamentals to make a vehicle safe. Okay, so this is very, very relevant topic for automobile as well as mechanical guys, and there is a huge amount of scope in this particular thing. Okay, I'm going to start with a video from Volvo, and that will give you a very good idea. Okay, clear, guys? PP, good. Yes, thanks a lot. Thanks, Uncle Panirudh, Bhushan, Siddharth, Ameya, Sushant, Abhijit. Yes, thank you, guys. Thanks. I'm really happy to see enthusiasm. I want this energy high. You should have almost 300% energy what you invest in regular learning, because in online learning, it is all your 2-3 basic senses. You have to listen, and you have to watch, and you have to, of course, think. Okay, so shall we start? Type in BIO, bring it on. Type in BIO, bring it on. So we will start with a video, very interesting video from YouTube. You can watch it anytime after this session. Also, I will put a link there. So type in bring it on, BIO. Yes, good. Thanks a lot. Okay, so let me share my screen, guys. And yep, so I'm sharing my entire screen, and you can, I think, actually see this. Can you see my YouTube video? Just type in YT if you can see my YouTube screen. It is stand still now. Rahul sir, the YouTube audio will be visible or audible to all, right? Am I right?
Yes.
It will be audible to all, correct?
Yes, audible.
Okay.
You can start and we will check.
Yes, so I'm just starting it. Okay, can you hear this? Rollover 30 miles per hour.
No.
It's not audible, right?
Not audible.
But is it visible?
Yeah, visible, clear.
No, but we still want an audio. So let me just check what I can do. I'm not sure with Google Meet, but in Zoom we have an option for switching on and off the shared audio. 1 second. 1 second, guys. Just hold on. Settings. Audio. Okay, fine. Video. Yep. I think that's fine. So what I will say, I will just make a commentary. It's like a mute video you are going to watch, but I will do a commentary. Don't worry. So let's play the tape again. Yes. The video is visible, right?
Yes, yes.
Okay. So I will just start from the beginning. Now, I will give you a context. Okay. Just write down whatever you feel very important. The byword for safety in automobile is Volvo. They invented the seat belts, they invented airbags, they made sure that their vehicles are safe till this date, so that there is no fatality, there is no serious injury. That means nobody is going to die if he is sitting in the Volvo. That's how they are committed to safety. That's why I'm playing tape for Volvo cars. Okay. No other car comes to this level of integrity when it comes to safety. Okay. You can go to Wikipedia and search how Volvo does, how Volvo works, all these things. It's a Swedish company, and make sure that you are understanding what is safety in the later part. I will be explaining anyway. Okay. So let's play the tape, and I will just commentate what is happening. Okay. So basically, this is a rollover test. Okay. This happens when not somebody hits, but when you are turning at a very high speed. Okay. And the center of gravity shifts, and then you are going to rollover. Okay, so that's a rollover test. Now what you have to watch is what happens to the roof and what happens to A pillar, B pillar, and C pillar. Okay, that is what you have to watch. So watch it clearly. Do you see any kind of a deformation? गाडी चपटी झाली आहे, एखाद्या माणसाचं डोकं त्याच्या आत चेंगरलं गेलंय. Nothing is happening, right? It's all integral. Can you see that? If you can see that, just type in yes. Okay, so I can understand what is happening. Can you see this particular area? This area has no deformation. That means the distortion of the vehicle, deformation of vehicle is not going to create a serious injury for occupants. Making sense? Okay. So type in yes if you can actually see no deformation, right? Now let's go ahead. I'll just create some interest in you guys. This is a slow-mo, and see what is happening inside. See what is happening inside. Okay. So very little deformation whenever it touches ground. Very and this is like 3, 4, 5 times or 3 times it is getting rolled over. It's not just one time. Okay. So it is not getting deformed. It is rolling over, and the occupants are safe. Can you see this? It's just juggling around, and they are having their seat belts on, and occupants are safe. Okay, so even if it lands on its head, it's still intact. That is how strengthy it is. That is how the biggest strength of Volvo lies in. Okay, so there are some bruises here and there. Some things are deforming. The door mirror is coming off, and there are few things which are happening. May not be structural. The headlight is gone, burst. Everything is happening, but inside it is not that particularly dangerous. Okay, agree? Now let me just zoom out this window, and I'll just create another screen here so I can pop in off. Yes. Okay. Now if you what do you have to watch here? This is a frontal impact, and it is a straight front. That means it is going to get hit directly onto a rigid wall with full fascia in contact with the wall. Okay, there are going to be many types of frontal impacts. This is the least severe because vehicle will absorb more energy. Okay, so now let's watch what is happening. Okay, so now I'll just explain you in slow motion. Yes, here you go. Now the important aspect here, which you guys as mechanical and automobile engineer have to look about, is this particular test is a one-time test. Clear? Everyone understands that you are not supposed to drive a vehicle once it is in a frontal crash or a rollover. You are supposed to tow it away. The second aspect is this may happen, let's say, with one car. So you're not going to meet it with another car. You may just directly hit on a wall or on a tree or somewhere else when you are driving alone. That is all possible. Now, the important aspect here is occupant should be safe. That's one part. The second part is there should be enough strength in this particular zone. Okay, you can see this particular zone. Okay, there has to be enough strength in this particular zone so that door should open once. After impact, the hinges, we all know hinges are going to be here, correct? So after impact, the hinges should be intact. If hinges are not coaxial, the door will not open. You can just imagine, तुम्ही असा विचार करा की लोखंडी कपाट आहे आणि लोखंडी कपाटाची जी बिजागरी आहे ती कोएक्सियल नाहीये, ऍक्सिस मॅच होत नाहीये, कपाट उघडणार नाही, राईट? इट विल बी लॉक. अँड the person who met an accident should be able to come out of the accident. Okay, so he will be safe, he will be alive, there will not be injuries. But if door is locked, door is jammed, and why it will get jammed? Either you have a deformation at the A pillar, this is A pillar, this is B pillar, this is C pillar. Either there is a deformation at A pillar or there is a deformation at door sill or shotgun area. So this particular area is called as a shotgun area. So this has to be very, very intact. So see what is happening in a slow-mo. Can you see this? It's tremendously steady. It is tremendously stiff. And that is how everyone thinks or says that Volvos are safe for 5-star safety. Okay. It is tremendously safe. You can see the speed. You can understand what will happen at this speed in a Maruti, for example. I'm a pretty much bad critic of Maruti cars because they are just craps for sure. Okay, so this is what is safety, vehicle safety. Okay, it has to be taken seriously because accidents can happen with your mistake or without your mistake. It can be somebody else's mistake, but accidents are always going to happen. Okay, so this is something you can see the accelerometers, there are going to be sensors, and they're measuring many things. What happens to engine, what happens to the drivetrain, what happens to the non-structural elements, what happens to the wheel, what happens to the front bumper. All these things they are going to understand. Even the windshield takes a lot of load. Okay, windshield also absorbs a lot of load. Now, okay, is this up to this point? Is it clear? Rollover and full frontal impact. So type in clear if this is clear to you. I will just read some comments. Type in clear if this is clear to you guys. Clear? So we talked about two types of dynamic analysis. So now this is the word which you have to write. Dynamic analysis or dynamic load. So write it down in your notebook. Definition of a dynamic load. We are going to learn also. Okay, through this video we are supposed to learn something. Dynamic load. So definition of dynamic load is very simple. Let me write it down for you guys in a presentation. So this is my company presentation, but for you guys I have just converted into a training material. What is a dynamic load? So definition, by definition it is very, very simple. All of you understand what is strength of material, design of machine element. You guys are from third year or final year engineering background, right? So dynamic load is load which changes its magnitude and or direction with respect to time is called as a dynamic load. Can you write this down, guys? Definition of a dynamic load. Once you are done writing, type in done in the chat box quickly. Write down definition of a dynamic load. Load which changes its magnitude and or direction with respect to time. This is important for crashworthiness design. Okay, and we are also going to come to what are the types of designs. Now, as you are understanding what is vehicle, so type in done. Once you are done writing, I want you to write it down. Don't take screenshots. I will share this presentation with you. Screenshots have no meaning. You will never go back to screenshot and learn from them, but you will always learn from your books, because it's your own writing and it's your own self. Okay, so write down what is a dynamic load. It is nothing but load which changes its magnitude and slash or direction with respect to time. Understood? Okay, now let's understand simple through simple example what is exactly dynamic load. Okay, I'll take a very simple example for you guys. The example is, let's imagine you have a shaft. Okay, the shaft is supported in bearings, so it is a fixed type of beam support, correct? So when it is in the bearing, when shaft is in the bearing, it is a fixed type of beam. It is not a cantilever beam, it is not a simply supported beam, because bearings are supposed to take what? They are supposed to carry bending moment. So there is going to be a bending moment, maximum bending moment at the support when it is a shaft. There is no resistance to shaft, it is freely rotating. It's just rotating about itself and it is free to rotate. There is no resistance, no torque, nothing. And I attach a pulley on this freely rotating shaft with mass equal to, let's say, 300 kilogram. Okay, so mass is equal to 300 kilogram for this pulley. It is perfectly balanced pulley, nothing imbalance in this, and we are having rotation at let's say, I'll not say omega, but let's imagine it is rotating at 3000 rpm without any load. So how are you going to analyze this shaft? It's a pure static load. Am I right, guys? It is a pure static load, because load is not changing its direction, it is not changing its magnitude. The magnitude is 300 kilogram multiplied by 9.81. That's the magnitude of force, and direction is downward, so it is not changing direction, not changing magnitude. That's why we can call it as a static load. Now if we apply some kind of an imbalance here, which is m dash on this pulley somewhere here, and this imbalance is going to create what? M dash r omega square, correct? So there will be an imbalance here, which is m dash r omega square. So this r is going to be radius between center and the mass. Okay, so that's the distance we are going to measure. And what is happening? This is constant because m dash you are not changing, but what the direction of load is continuously changing. It is continuously alternating, right? So what is happening to the bearing? Once it is going to get pulled in this direction, the other time it is going to get pulled in the other direction, and so on. So there is going to be a continuous centrifugal force which is going to pull bearing in all directions as time changes. Okay, and this is something which we'll be calling as dynamic load, because it is not changing magnitude, but as per definition it is changing direction. Are you clear with this particular example, guys? Type in clear if you are clear with this example, so that I understand. Or if you have questions, just type in the message box. Okay, Suraj says clear, Chinmay says clear, Prathamesh says clear, Aniket says clear. Clear about dynamic loading concept. So load changes its direction or magnitude with respect to time will be called as a dynamic load. Okay, so there are going to be 4 types of dynamic loads in industry. Okay, so I'm going to talk you through with the dynamic load in the industry with 4 domains. Okay, so I will talk about it in terms of domains. The first domain is what we are discussing today, crashworthiness. Okay, that's first domain. The second domain is impact. When I say impact, it is at, let's say, 1 kilometer per second or 600 meter per second. I'm talking about high speed impact in event of explosives, in event of missiles, in event of bullets. Okay, I'm talking about defense. So first of all, we are talking about automotive. The second thing we are talking about is defense. We are talking about domains. Okay, this the third part or third type of application for explicit dynamic analysis is drop test for household equipments. So let's imagine hair dryer, mobile phone, this mouse, this digital pen, maybe our maybe the household equipments like in transportation they may get dropped, which are let's say washing machines, dishwashers, or microwave ovens. They go under drop test. So everyone, Samsung, LG, then Whirlpool, everyone uses LS-Dyna for their drop test analysis or impact analysis or G loading analysis. Okay, and the fourth type is blast, which is a shockwave propagation phenomena, happens in a millisecond, 1, 2, 3 millisecond, it's all done. So this is something which is causing us to actually understand what is explicit dynamic domain. There is a tremendous shortage of resource for crashworthiness, for impact, for drop, and for blast. Take my word. There is a tremendous amount of engineering talent shortage. Engineers are talented, but they are not having skills. They may be having skills, but they are not aligned to the product. They may be aligned to the product, but they are not having exposure to the software tools. All these things are causing a lot of problem in the industry. There are tremendous opportunities, but we are not able to cater. Reason being, we are not good in basics of engineering. That is first reason. Second reason is we are not getting exposed to the newest technology. And the third reason is we are not actually focusing ourselves on a specific niche. The word is niche. Okay, so this is analogous to specialist, super specialist in medical domain. So if you go to any medical field, there are going to be super specialty hospitals. So if there is a problem which is very intricate, very detailed, you need a super specialist to solve that problem. That is something we all should strive for. And my next point about this is subject matter technical expert as your goal. Okay, imagine. So let's talk about this. I will give you time to ask questions. Let's talk about this in 1 minute, and then you can ask me questions. Subject matter technical expert. What is it? Subject matter technical expert. Who is this guy? This guy is a go-to guy who is going to solve your problem in a specific matter, in a specific subject, not a generalist. Okay, not a general practitioner. He is a super specialist in a particular subject. So you cannot be a super specialist on first year, second year, third year, even 5th, 6th, 10 years. You have to invest your time in understanding what? Understanding a product, not a tool. So tools are not important. There are many training institutes who are training or giving training for 6 different tools in one course, 5 different tools in one course. You are supposed to choose your domain first, and domain will actually lead you to tool. So if you, let's say you choose a domain for crashworthiness, then automatically the tools are going to narrow down. So if you are choosing a domain for crashworthiness, your tools will be either Abacus Explicit or LS-Dyna or Radios or PAM Crash. Now you have to check for the mentor, whether I have any mentor to train me on these subjects, and then so on. You are supposed to go on searching for the goal to become SMT. Okay, why you need a goal? I'll just give you a simple example. Goal setting is very important for every engineer, for every human being, to be frank. Imagine you are having a ship, very capable ship. There are 2 ships. Okay, very capable ships. They can sail at a speed, they can sail for long distance, they have abundant energy, resources, everything. And they are exactly same. One is having a captain. There is someone to sail this ship. The other is having no one on it. It's just a ship with all the equipments. You turn both of them on. This is on, this is on, and they started riding in the ocean. What is going to happen? The captain will take this ship to destination. 99% of the time, the ship will reach its destination. But what is going to happen with this ship? It may land on an island. It may land somewhere, or it may just go haywire and go somewhere else. And fuel will be done, and the ship will be abandoned. nobody is going to look at it. So what is importance of a goal? The destination is something which will decide whether you are in process of exceeding your own capabilities. Okay, so you have to compete with your own self. You don't have to compete with somebody else. You have to compete with your own self and make sure you are reaching to the goal. And why I'm talking about this particular topic just in 1 minute. Subject matter technical expertise is not tool expertise. There will be lot of bombardment on you to do lot of design courses, CAE courses and all these things. First of all, you have to think about your own understanding of that particular subject. You have to think about, as a student, it is your responsibility to choose a domain. And as I have listed for explicit dynamic, these may be the domains. So is this the end? No, there can be maintenance, there can be production, there can be planning, there can be sales department. All these departments are still mechanical departments. But if you are really interested in design, if you are really interested in analysis, then these 4 domains are very, very good for next 10, 15, 20 years. Reason being, we are now rolling ourselves back for defense procurements. What are we doing? The government is so worried on front that there should be an indigenous equipment made in India, designed in India by the Indian company for the defense applications. For last 70 years, we were not doing that. And now it's completely new domain. So everywhere, the explicit dynamic analysis plays a very important role. Are you clear, guys? Is this clear? Is this making sense? Type in MS if it is making sense. MS if this makes sense. Quickly. Is it making sense? Any questions you have? Just type in if you have any question, and we will go back to the Volvo video. Yes, good. Nice to see people understanding. You are not getting bored, right? Interesting. Type in interesting if it is interesting. I is okay. Just use short forms. Okay. So good. It's interesting. It is really interesting, and it is rewarding as well. You will be getting good jobs once you invest some couple of years in learning it. Okay, you need a good amount of learning there. It's not just like you join some company for an internship and then they start giving you salary at 6 lakhs per annum or 10 lakhs per annum, right? You have to invest your time in learning. Capabilities should be showcased, and then everyone will be in a position to absorb you. Fine. Okay, now let's go ahead and talk about Volvo. I will read out. This is a small overlap, 25% offset at 40 miles per hour. So 40 miles per hour is 64, that is 64 kilometers per hour impact. Okay, so 1.6 mile, 1.6 kilometer is 1 mile. So this is almost 64 kilometers per hour impact. Okay, and this is a small overlap. Small overlap is worst. Worst in the sense, you have a driver side. Let's say you are a driver, and there is going to be an oncoming traffic, and this is a top view. This is a full head-on collision. This is not very severe, okay, because the other car is also going to absorb energy. This is 40% offset, and this is 25% offset. You can see my hands, right? So this 25% offset leads to severe injuries. There are going to be cases where the dead body was not actually in a position to extract out of the car. You have to cut the car altogether, and then you have to extract the dead body. That's the severity of a frontal impact. Okay, so let's see what is happening with a small overlap. Okay, so it is this is called as a sled. Okay, this is called as a sled, and you can see what is happening. It's a rigid impact, and can you see this? It's like vehicle flowing as a fluid. Okay, it's like vehicle flowing as a fluid, and it is getting away from the barrier. Now let's see the top view. Let's see the occupant. What happens to the occupant? Can you see a pillar, guys? It's not deforming much. There is good amount of occupant space, and this is Volvo. Okay, so there has to be an occupant. The front wheel had just sheared off. It's out of its way. Can you see this? The wheel is not there. It just came out. Only 3 wheels are there. The 4th wheel is not there. And okay, so I will replay for last 5 seconds. You have to watch for the seat belt. Guys, be careful and watch what happens to the seat belt. It automatically gets pulled. Okay, that is called as a pre-tensioner. So watch it carefully. Yes, can you see this? I'll play it again. Watch it carefully. Watch it carefully. The belt gets pulled, and that is to make sure the occupant is not moving around. The occupant is exactly in a position which vehicle wants it to be for a frontal impact. Okay, and the wheel sheared off, everything sheared off, no structure is allowed or able to withstand the load, and the vehicle just flows, and it is still stable. Nothing happening. Can you see the amount of forces coming on the A pillar? The A pillar is so thick. So I will give you an assignment. I will give you a very, very important assignment. Guys, are you listening to me? Okay, type in L if you are listening to me. Okay, I will give you an assignment. You have to go on road and type in L if you are listening to me quickly and write down the assignment. Write down the assignment. Okay, the safest car in India right now, there are 2 cars who 3 cars, I will say 5-star safe rated global NCAP cars. The first is at the top, it is XUV 300 Mahindra. The second 5-star car is Tata Nexon, and the third 5-star car is Tata Ultros. No other car is 5-star. Okay, so these 3 are the homegrown cars who are 5-star cars. Now you have to watch, you have to differentiate by looking at A pillars of any Maruti car. Okay, any Maruti or Toyota vehicle, A pillar is what we saw near to the driver, and see these 5-star rated, maybe XUV 300 or Nexon. Look at the A pillars of these 2 cars. Okay, the 5-star cars, you will feel the difference by just looking at it. There will be a tremendous chunk of A pillars in front of you, and the reason is this test, the test which we saw right now. Small overlap, because this is a global NCAP test. This is a 25% offset at 64 km/h. Passenger should have no injury at all. That's the test, and that's why the vehicle is designed according to the test which it is going to undergo. Okay, so anyone repeat the assignment? You have to see the difference between any of the Continental cars, Hyundai, Maruti, and check the A pillars for XUV 300, check the A pillar for Tata Nexon or Ultros. Okay, can you do that? So just type in can do. We can do this assignment. Just type in can do and click some photos and send it to me on my LinkedIn. So you have to connect me on LinkedIn. You can do it, right? Just go outside, look at anywhere you see Nexon standing, just look at the A pillar. Look at the A pillar and you will feel how that car is designed for safety. Okay, I own Nexon, I proudly own Nexon. Only reason was safety. Okay, because I'm working in safety, and if I'm not buying a safe car, makes no sense, right? So you have to do this. Yes, thanks a lot, guys. Thanks for replies. I'm pretty happy that you are learning a lot of things by doing some assignments. Okay, get some pictures and search me on LinkedIn. How many of you are there? Yes, Ultros is a 5-star car. Correct, Krish. So how many of you are on LinkedIn, active on LinkedIn? Type in LI if you are active on LinkedIn. LI. On LinkedIn, you are active, right? Yes, good. So what I want is, I want you guys to send me an invitation. Search for my name, Nachiket Phadke, and send me an invitation. But you have to send me an invitation with a note. You should not send me an invitation which is blank. You should send me an invitation stating that I attended a Crashworthiness webinar and I would like to connect with you for better connection or for better visibility in the market. Because let's imagine I have some 11,000 followers on LinkedIn. Those 11,000 people will be able to see your profile when you are going to do something, when you are going to do an assignment. So this assignment, if you prepare, let's say, one simple slide where you are putting a comparison between a 5-star safe car and a regular car, you will be actually getting noticed by many people in my network. Are you getting my point? Okay. So don't do it right now. Do it after the session. I will not accept a request without a note. Okay. You should be requesting me to get connected. This is a habit, not for me. This is a practice for you to get connected to industry people. You can connect to CEO of Tata Motors. You can connect to Chandrasekharan of Tata Sons. You can connect to anyone on LinkedIn with a very, very good note. Okay, if you are not putting a note, if you are not very clear with your own self why you want a connection, then nobody is going to connect with you. Okay, so can you do that? So 2 assignments I have given. The first assignment is you have to check or compare between 5-star car and not a 5-star car. The second assignment I gave you is to give me or send me a request on LinkedIn stating you attended a webinar on crashworthiness at RMCET on 7th of October. Okay, can you do that? Type in yes if you can do that, and then we will move on to the next important topic. Again, I will try to show you some videos, but this time I will be showing you a live session. What is luggage retention and what is a design by CA? That's our topic, or design for crashworthiness. Yes, okay, good. Thanks, Pranay, Shubham, Chinmay, Omkar. There are many, 3-4 Shubhams I saw. Okay, and Anirudh, Rahul, yes, thanks a lot, guys. Thank you very much. Thanks, Mayur. So let's move on to a tool which is free for everyone. This tool is free for everyone. This is an LS-PrePost, which is a pre and post processor for LS Dyna. But in this particular tool, you can just go on website or internet, and what you have to search for, I will just show you what you can search for. You can search for LS space pre space post. That's all. Once you search for that, you can go to Livermore Software Technology Corporation. You can go to LS-PrePost download and just download the version which is the latest one, maybe 4.8 Windows 64, and just download it. Okay, this is a simple exe file, no licensing required. What you can do using LS-PrePost, you can create geometry, very simple geometry. Okay, I'm not talking about a CAD tool, very simple geometry. You can open IGS and step file for free, and you can mesh those IGS and step files for free. So you can do a meshing using LS-PrePost for free. Okay, you don't need any licensing, nothing. Clear, guys? Can you do that? So I'm giving you a lot of things. You have to be very, very busy with your pen and paper. Okay, so LS-PrePost, that is what you have to search for. Can you do that? So search for that, and later you can actually see it or actually use it. Very simple, straightforward. If you want help in learning LS-PrePost, we have a small course at a very small fee, which is available on Teachable. You can just connect me on LinkedIn, and I will push you what course you can go forward with. Fine. Okay. Now let's understand with regards to this particular presentation, the applications of crashworthiness, the applications of explicit dynamic domain. Okay, so I will just show you some applications right now. Let me check if I have another presentation. Yeah, okay, so this is a bus rollover presentation. Okay, I just wanted to show you some animations, but anyway, so I will show you animation here. Yes, so you can see a vehicle seat. This is a car seat. This is not any company seat. This is from GrabCAD. Okay, you all know GrabCAD, right? I'll just type in what is GrabCAD in the comment box, and I think it will be easy for you to check. So all of you know GrabCAD. GrabCAD. Okay, I've just put a name, grabcad.com. It's a free site where freelancers upload their designs, and you can download it for free. So this seat is not any company seat. I'm not allowed to show any company presentation or company designs here. This is a free seat available on GrabCAD. Okay, what we did is we meshed this seat using elements, nodes and elements. So you can see it here. Can you see this? So you can see the meshing. There are many holes available. This is a track. There are connections. There are wires being defined. There are connectivity done. This is a plastic panel. This is a head restraint rod. This is a luggage block. Okay. So I'll just show you what it is. What is this test? This test is called as luggage retention test. Okay. This test is called as luggage retention test. Okay. Can you write it down? The name of test as, I will also write it here. The name of test is luggage retention test. LR, and it is as per ECE, that is Economic Commission of Europe, ECE regulation R70. You can search this regulation. This regulation is available free of cost to everyone. Okay. So this luggage retention test is also called as frontal impact unladen. Okay. Unladen is nobody is sitting in the seat and still we are doing a test. Okay. So what is happening in this test? There is a luggage block. The block is not moving. Block is stationary. It's a frontal impact. That means vehicle is moving forward and there is a resistance to move it further. Okay. So vehicle will move in a rearward direction when there is an impact. Okay. And because luggage is not part of, so I'll just annotate. Okay. So annotations are not available. Okay. 1 second. I will just do a print screen and put it here. Yeah. Okay. I'll do a print screen. And put it in our, this presentation I will share with you. Don't worry. Yeah. Okay. So if this is a seat, what I can annotate is this luggage is not part of vehicle. Not part of vehicle. This is an independent entity. This complete seat is a part of vehicle, including this floor, BIW floor. So what is happening in a frontal impact? Vehicle will move in a rearward direction after the impact or in the impact, not when it is moving. So it is moving and it hits, and once it hits, it's going to rebound. So we are talking about only the crash scenario, not pre-crash. Okay. So this is going to happen and vehicle is going to move in a rearward direction, but because of luggage inertia, luggage will try to remain stationary. Am I right? Simple physics. Luggage will try to remain at rest. It will try to do or keep on moving with the same velocity. Am I right? And the vehicle will move in a rearward direction, which is going to create a havoc situation. I will just show you how it is. So if I just go for animation player and run it, this is the other way around. I will just remove the anchor point. So follow point I'm going to reset. Yep. So this is what is going to happen. The vehicle will move in a rearward direction and luggage will try to remain stationary. This is called as a luggage retention test. This is highly dynamic, non-linear, explicit scenario. I'll just slow it down for you guys to understand what is happening. Okay. This luggage is of some 18 kilogram and it is 300 by 300 by 300 cube, and this luggage is going to hit on the seat back, and there is going to be tremendous amount of deformation if the seat is not particularly stiff. Okay, so we saw in our first session what happens to an overall vehicle. Now what we are looking at is what happens to this particular seat. Getting my point? And this is very, very, very important. Okay, very important. Clear? So this is something which we do using explicit dynamic analysis in LS-Dyna. This is what we do in LS-Dyna. This is what we strive for in LS-Dyna. Making sense? Okay. So this is the luggage retention test. Have you understood the physics of this test? Type in LR if you have understood physics of this test. Don't worry about the tool. It doesn't matter. So if you have understood physics, type in LR if you have understood it. Okay, so Mayur says LR, Srinath says LR. Good. Vinay, Pratik, Atharva, Shubham, Chaitanya. Good. Thanks a lot, guys. So it is about conservation of momentum. Law of conservation of momentum. That is what it is. Okay. MV equal to MV. The law of conservation of momentum is going to play a very, very important role in absorbing the energy. And this is called as explicit dynamic non-linear analysis. So shall I write it down, guys? What it is called as explicit dynamic non-linear analysis. Explicit dynamic non-linear analysis. Okay, and this is done using LS-Dyna. This can be done using PAM-Crash. This can be done using Abacus Explicit, and this can be done using Radios. Out of it, the market share is 95% for LS-Dyna. All these three are just 5%. Okay, that's why I teach or learn LS-Dyna continuously. Okay, so LS-Dyna is for our company, for defense projects and railways project. For our company, LS-Dyna is the single solver. Okay, I will show you another application of LS-Dyna for modal analysis, that is frequency response analysis. So there is no load here. This is just a seat connected to each other. The first 6 modes are going to be 0. You can watch this value. This value is minus 8.17 10 to the power minus 6. So it's close to 0. That is in terms of hertz. Okay. So the first frequency is 0, and you can see what is happening. This is a natural frequency. So natural frequency for unconstrained object is always going to be 0 because it's like in space. So the natural frequency is under root of k by m. You all know that. You have to be very, very clear with basics. That's why I have also created a course called Basics of Engineering. Okay, it's a free. It's a course when we actually give it as a bonus when somebody joins in LS-Dyna training or LS-PrePost training. Okay, so that's a very, very basic course, but it is very important for you to understand basics of engineering with respect to CAE, okay, or computer aided engineering. That's another course which we have. So basically this is first mode. Now let's watch what is happening to the second mode. So this is rotational mode. Can you see this, guys? It's rotational mode about y-axis. The complete seat is rotating about y-axis. So we can call it as RY. The next mode. This mode is something looks like rotation about x-axis. Okay. Let's see whether it is rotation or pure rotation or translation. This mode is something which is rotation or translation, either rotation about z or translation about y. Okay, we'll figure it out. Then you have another mode here. You can clearly see this is clearly a rotation about y. So earlier was translation. This is also kind of a rotation, and this is also kind of a translation. So you can distinguish between various modes. These all are zero modes, zero frequency modes, which are also called as rigid body motion. So in your dynamic subject, when there will be vibration and balancing and all these things, you will be looking at this particular topic. And now the 7th mode is something which is a local mode. So these two parts are not connected to each other. That's why you can see the motion like this. Okay, these two parts are not connected to each other, so you can see the motion. Okay, these parts are not connected to each other, this area, whereas this area is connected. So it is moving according to the connection, and this is not moving according to the connection. Are you clear, guys? So type in modal if you are clear with the frequency analysis. This is a natural frequency analysis, not an excitation frequency. Okay, first 6 modes are 0, and next modes are going to be something which is which can be caused by constraints, okay, or not constraints. Okay, so type in modal if you have understood what it is. I will give you a sufficient amount of time to think about it and come up with the question. I will be happy to answer it anytime soon. Okay, so type in modal if you have understood it. If not, keep question with you and I will try to answer your question with subsequent videos, or maybe we'll have a separate interaction for B students for their dynamic analysis subject or dynamic subject. Okay, we can do that. Clear? Interesting? Are you learning something? Type in learning if you are learning something. Okay, just 5 minutes, but you are learning something, right? Shubham Pagade, you are learning something. You should be waking up, sitting straight. Don't lie down. You are not a Shesha Vishnu to lie down. Just wake up. It's for you, not for me. Okay, good. Thanks a lot, guys. You are learning something that matters most to me. Okay. Now we will understand what happens. Okay, what happens in vehicle design. Okay, so we are going to talk about what is the vehicle design principle for crash, or why we use crashworthiness to design the vehicle, and the important learning topic for today's session. We are coming to an end. Only one topic, this topic remaining. Crashworthiness. Before we go and crashworthiness design, that's the important topic. We should understand types of designs. Okay, so types of designs. The types of designs are static load, static design, dynamic load, static design, and there is going to be a dynamic load, dynamic design. These are the three principles of design for any structural problem. Okay, so static load, static design is you designing a chair, you designing a table, you designing something which is like a water tank or a structure, skeleton. All these things are coming as static load, static design. Your load is also static. It is not changing its magnitude and or direction with respect to time. And your design is also static. You are using simple principles, sigma is equal to P by A, simple simple geometries. All these things are coming under static load, static design. The second part is dynamic load, dynamic design, where the important aspect is dynamic load, because your principles remain same. They are going to be static design principle, simple principles of P by A is equal to sigma and all these things. Dynamic load will be the load which changes its magnitude and or direction with respect to time. So it can be bridges. Okay, one time it's going to be crossing the bridge with a bus. Other time you will be crossing a bridge with a four-wheeler, simple car. The other time you will be crossing a bridge with a JCB. So what is happening? The magnitude is continuously changing. Direction remains downward always for a bridge, but it is a dynamic load. But what we do, we convert this to an equivalent static load. And there you will use a static design principles itself. You will have factor of safety of 10. You will have factor of safety plus there will be some additional conversion factor for dynamic to static, and you are going to design it using simple static principles like this. Whereas dynamic load and dynamic design is completely different. You cannot use arithmetic, simple arithmetics for doing dynamic load and dynamic design. You have to work using numerical methods and CAE. Then only you will be you either numerical methods and CAE, of course. So numerical methods are part of CAE, or CAE is derived from numerical methods. So whatever is this kind of a design, whatever you are looking at it, this is a time domain. That means your abscissa is time always. Abscissa is always going to be time, and in this particular case, you applying simple principles of converting a dynamic load into an equivalent static load makes no sense, because you are never going to get similar results. So for example, if this block is of 300 kilogram, 18 kilogram, and it is moving at a speed or acceleration of 20 g, so mass into acceleration, it will create a force, correct? If you try to apply a static force which is equivalent to this dynamic load, you may not get similar results. You are never going to get similar results, rather I will say. Making sense? You are never going to get similar results. You are going to get a completely different result in that aspect. Is this clear, guys? Okay. So these three principles you have to watch for. That's why cars are always designed by taking into account dynamic load and dynamic design practical application. Crash is dynamic load, dynamic design. Rollover is dynamic load, dynamic design. Impact is dynamic load, dynamic design. Blast is dynamic load, dynamic design. Making sense? Okay. So up to this point, everything clear? Anyone has a question? Type in your question if you have. I will just watch it now. If not, just type in clear. Just type in clear. So I will be assured that whatever I tried to teach you today is actually was passed in a clear way. Type in clear if you are clear. If you have a question, type in question. I'm looking at the comments now. So Chinmay says clear, Pratik says clear, Sanket, Srinath, good. Okay, clear. You learned something, right? Good, good. Thanks a lot, guys. Thanks for replies. And what I will tell you is stationary body with vehicle's front impact. See, you are not designing that body, or what you are designing a vehicle crash. So basically it's a frontal impact. That means it's a dynamic load, dynamic design for sure. But if you are designing that body, still it is dynamic load, dynamic design, because you are not supposed to just take into account an equivalent static load of that dynamic load, right? So your equivalent static load will never match to the dynamic load. Okay, yes, good. What is the reason behind through though car like Scorpio? Yeah, because they are not designed for safety. See, if you haven't designed this pen for drop test, what is going to happen? When you drop this pen, it is not going to work because your design was not that way. Okay, what was the design for previous phones which are having removable battery? If you drop those phones, they will just spark away, so energy will get diverted from important components, and you can put everything on and your mobile starts up. That's an energy balance principle. Okay, very good question. So it's an energy balance principle. How to know safety rating? It is all going to be on internet. So you go for NCAP. Oh, good question, guys. So if I go for global NCAP, global new car assessment program, what is NCAP? Write it down in your notebook quickly. NCAP, new car assessment program. Okay, so if I go for global NCAP and just go for India, global NCAP India car. So whatever cars Indians have produced, those cars are getting tested there. Okay, so if I go for, let's say, safe cars for India is the hashtag. That's a crash test result, and you can actually get a complete chart of which are the tests. These are 4-star cars. So even Tigor is a 4-star, XUV 300. So you can see this Tigor, Tata Tigor, 2 airbags. It is having an adult safety of 4 stars, and this safety of the child safety of 3 star. Then you have XUV 300 with adult safety of 5 star, as I mentioned, and child safety of 3 star. Ultros, can you see this? It is 5-star safe car. No Baleno, no I-20, nobody is safe. Okay. Ertiga, it is 3-star rated car. Okay. Wagoner, it is 2-star car. Hyundai, it is 2-star car. Santro, Datsun, it is 1 star. Okay. Tata Nexon, can you see this? It is a 5-star rated car. Mahindra Marazzo, you have a 4-star rated car. Then you have Swift. Can you imagine, guys, what is happening in the market? 1.5 lakh cars Maruti sells are all craps. They are not made for safety. They are only made to run with a mileage, and who knows what is the resale value. You will never get a resale value if you are not going to survive in a car crash, right? So it's not going to be a safe car. You can see all Maruti cars down there. Brezza accidentally went for 4-star. It's not actually a 4-star. I will not buy it for. This is a 0-star car, no airbags. The Logi has no airbags. Nexon previous version, the first version, 2018, it's a 4-star car. Duster, no star. Can you see this? No airbag, no star. Okay, Renault Duster, you can see this again, driver airbag, and you get a 3-star. Then you have Enjoy. It's a Chinese. It was a Chinese car done by Chevrolet, so I would never expect it. Ford Aspire 3-star car. Zest, it was a 4-star rated car. Zest no airbag, 0-star. If you have no airbag, you are getting a 0-star car. Can you get this? It's all freely available. It is all to do with what you understand from a vehicle. Are you looking for a safe car, or are you looking for a cheap car, or are you looking for a car which is having some kind of an embargo for serviceability and after sales service and what it is, second hand value? Doesn't matter if you are not going to survive in a crash, right? So you have to invest, you have to search for a very, very good car. Can you see this? Hyundai. No Maruti, no Hyundai has 4-star rated car except that Brezza. Can you imagine? First two places which we as Indian consumers give is for a non-safe car. Okay, because we run around for 1 kilometer per liter or 1 kilometer per liter extra mileage or 2 kilometer per liter extra mileage. The mileage comes because there is no weight. There is no weight because these cars are not designed for safety. Okay, you can see the A pillar for Nexon. You can even see A pillar for XUV 300, and you can see the A pillars for these guys. Can you see this? Okay, you can see the A pillar for XUV 300, how bulgy it is. Okay, and that's for a reason. It's not because they don't know what is happening. Okay, clear, guys? Making sense? So, is there a crash test for commercial vehicle? Typically, no. Reason being, there is a test which is rollover, bus rollover, which I saw you. Okay, so the rollover test is for sure a crash test, but it is a dynamic test, but it's at a slow speed. MG Kia, no star ratings. They have 5-star cars outside India, but whatever cars they sell in India are substandard. They are using substandard materials. They are using substandard thicknesses. Their weights are different. You can just watch on India-bound Kia cars and European Kia cars. They have a 200 kilogram weight difference. Clearly, it's all there on website. I'm not saying it with my own words. It is all there on the website. Okay, so they are having 200 kilogram difference in India, and in Ford is now pulling off the market. So Ford is having good safe cars, but again, they were very slow in updating their vehicles, and now Ford is a part of Mahindra dealership. Okay. Yes, so safety pillars or the A pillars, B pillars, you will get an idea. Okay. It is there. I told you this is global NCAP. You can just go here. Can I give you this this link, guys? The link is with you. Global NCAP results. Is that yeah, of course it's according to Indian road conditions. Road conditions doesn't matter, your speed matters. It's the speed at which you are going to crash it. It's at 64 kilometers per hour. That's the worst speed anywhere in the world. Nobody tests any vehicle more than 64 kilometers per hour, and it's all going to be offset crash. Okay, clear, guys? Any questions you have? Learned something, correct? Understood? Interesting? You actually understood what is happening in the vehicle world, right? This is just about vehicle. There are many things which are happening about defense applications, blast, impact, penetrations. Then there are armored vehicles and all these things. That is also done using LS-Dyna. Okay, so you can get, as I said, there are 4 assignments. The first is you have to get connected with me. Before that, you have to look for the A pillars of 5-star cars and non-5-star cars. Now I have given you list of non-5-star cars, so you can just go and watch it. Mayur is asking a question: why Indian car manufacturers not promoting child safety mounts? Because it's not mandatory from government. So all the cars which are 5-star are having a child safety mount as an inbuilt safety feature. Okay, otherwise they will never get a 4-star rating for sure. Okay, so LS-Dyna, you can learn from me. Hypermesh is a good tool to learn LS-Dyna, but it's not absolutely mandatory for level 1. But you can learn, Krish, you can get connected on LinkedIn and you can learn. This is not a promotional lecture. I really wanted to share some knowledge with you, but I am an LS-Dyna trainer for last 15 years, 16 years. So I can train you very well. We are anyway running the course continuously. So you can just get in touch with me on LinkedIn. I will update you. My preferred platform is LinkedIn. So if you want to find me, just watch me on LinkedIn. Okay, I don't promote. I go live on LinkedIn, which is a feature available for privilege only. It is not available for everyone, but I can go live on LinkedIn. Okay, so that's how I interact to everyone on LinkedIn. It's the most sober and professional platform. I don't like a lot of things happening on Facebook and Instagram. I'm there, but it's my team who is promoting it. When you want to see me, you have to come on the LinkedIn. Okay, so the first assignment was to check 5-star, non-5-star car. Second was to send me a connection request on LinkedIn with a note. Third was, what was the third assignment, guys? Anyone? I just went blank. So third, we did four assignments. So you can go to Global NCAP and that's the fourth one. Anyone remembers the third assignment? Anyone wrote it down? You can watch for this numerical methods or something like that I told you. So just let me pull this off. Explicit dynamic. Yeah, LS-PrePost. Yes. The third assignment was to download. LS-PP. Go on the internet and download LS-PrePost. It's a free tool. You can just download and start working on it. Working in the sense you can create some simple geometries, create some good mesh. All these things are possible for free on LS-PrePost. And of course, fourth assignment is this one. Yes, Akash, that's the reason. Maruti Suzuki they gave a press statement that we are not going to go to Global NCAP. They made a press release because their cars are crap. Okay. Yes. So guys, it was nice interacting with you. It was amazing crowd. You were energetic. I'm really very happy and I'm happy to be here in future also. I will be happy to be here in future also. So thanks Rahul sir, thanks Sachin sir, and thank you Bhagwat sir also for actually attending the session for initial 10-15 minutes, and it was really nice interacting with you. So over to you, Rahul sir. Oh, you are there. Wow.
Yeah.
Oh,
Yeah.
yes, thanks a lot, sir. Yep.
It was wonderful. Yeah.
Okay, over to you, Rahul sir.
Yes, sir. Thank you, Bhagwat sir. Thank you, Waghmare sir. And thank you, Nachiket sir, for this wonderful session. And I'm also thankful to all the students. So, almost more than 70 that were continuous.
Yeah.
Initially, it was 100, but because of some network issue, might be some students in between they lost their connection. But I'm sure the students must have learned a lot through all these various tips and assignments which have been given by Nachiket sir. So definitely we will be trying to plan some more sessions,
Yes.
and especially automobile engineering students in the final year, they have a subject vehicle dynamics.
Okay.
So vehicle safety, vehicle dynamics, these are the subjects, and definitely Nachiket sir's input will be very helpful for faculty members who are dealing with these subjects, and for students also to learn the subjects with more practical aspects of the subject. So thank you very much. Bhagwat sir, with your permission, we can conclude.
Yeah, sure. Yeah, looking for the similar request. It was really wonderful.
Thank you.
Yes, sir. Thank you. Thank you.
Okay. See you. Bye, guys. You're most welcome, guys. Bye.